Activity 8.2 under one condition. Kieran notices the probabilities from the warm-up can be arranged into at least two equations. So Kieran is looking at activity 8.1. So if you're looking at all of these different probabilities he has, he's looking up at the previous example, and he notices certain things about his probabilities. The first thing you notice is that when you take the probability that the card is a queen and a heart, which we did with part 1C, we found the probability of the card being a queen and a heart is 1 out of 52. Then for number 2, when we just trimmed down to the hearts, we noticed that it was 1 out of 13 for the queens, given that it's a heart. So we took it the hearts first. Out of all those hearts, there was only one that was a queen. So that's where that one comes from. And then this one, the probability card's a heart, that's from part B. Number 1, part B, that's this right here. And what Kieran notices, when you multiply these two here in green and blue, you always get the red one. Interesting. He then switches up the order. What if our 1 out of 52, that's the same thing that we got in part C up above. Well, what happens if we just focus on the queens? What happens if your card is a queen? Well, there's only 4 queens in the deck, and only one of them is the queen of hearts. So that's where this one comes from, 1 out of 4. And if we take that, the probability card's a queen. Well, that's from part B up above, number 1, part B. That's where our 4 out of 52 comes from. Okay, so maybe that's from part A, excuse me. So Kieran noticed that these multiplication, this is true. He wonders if it's true. This is our multiplication rule. He's wondering if that's true for more examples in a deck of cards. So, I don't know, maybe he's right, maybe he's wrong. I have no idea. Let's take a look at the next example. All right, let me clear the screen here. All right, so now event A is the card is black. Event B is the card is a king. Does the equation hold true? Okay, so let's set up our equation that we have here. So we are comparing is the probability of A and B equal to the probability of A given B times the probability of B. Okay, so first of all, the probability of A and B, let's find that probability first. A and B. Well, that's going to be the card is black and it's a king. So I need to go down below here. How many black kings do I have? Well, in this case, I have a king of clubs and I have a king of spades. So that's 2 out of 52. Great, got it. Now I have to find the probability of A given B. So that's a conditional probability, the probability of A given B. That means, given the fact that it's a king, so we know we always start with the denominator. Miss Lee told us this a couple weeks ago. Always start with the denominator. How many total kings do we have? We have 4. Out of those, how many of them are black? Well, we already said there's 2, so that's 2 out of 4. The final thing I need to find is just the probability of B happening by itself, and that is that the card is king. Well, what's the probability you're going to reach into a deck and pull out a king? Well, there's 52 total cards in a deck, and there's 4 of them that are kings. So, moment of truth here. We go over here and we set up our equation. So the first part, probability of A and B, is that the same thing as the probability of A given B, that's right here, times the probability of B happening by itself. Oh, baby, I'm nervous. Okay, so now what we have here is 2 over 52 drops down. What we can do is we can cross cancel here. This 4 cancels with this 4. And the only thing that's left is 2 up top, 52 on the bottom. Hey kids, all is right with the world. This definitely checks out for that scenario. How about event 2 or number 2? Actually, I'm going to stop there and we'll take a look at this one in a separate video because I'm almost out of time.